Hi friends, today we are going to discuss about the distinction test between aldehydes and ketones. So how do we understand the presence of aldehydes? How can we distinguish these two different compounds? And not only that, I'll be discussing some reaction for phenol and as well as carboxylic acid. So let's start with the first test, which is tolerance test. Tolerance test or tolerance reagent. Tolerance reagent is ammoniacal silver nitrate. This is how we are representing ammoniacal silver nitrate in a chemical reaction. AgNH3 twice plus OH minus. And this test is applicable only for aldehyde. So only aldehyde alone gives this test. It will not be for the ketone. So ketones do not undergo tolerance test. So if you have an aldehyde and a ketone, we can use tolerance test to analyze between those two. So RCHO is aldehyde. When you add tolerance reagent, it helps for the oxidation. So CHO, this CHO aldehyde group changes to COO minus carboxylate group, carboxylate anion group. So aldehyde changes to carboxylic acid, and as a result you will be getting Ag. Ag is a silver mirror deposition. So if you are doing it in the lab, you will be getting the silver mirror observation in the inner wall of the test tube after heating. So aldehyde undergoes a reaction with the tolerance reagent, you will get the observation like silver mirror observation. But the same reaction if you are doing for a ketone like RCOR, when you do the same reaction, there won't be any characteristic observation. No characteristic observation for ketone. That is the first one. And this test is applicable for both aliphatic aldehydes and aromatic aldehyde, RCHO and ARCHO. Both will be answered. Now Felling's test. Felling's test means there are two solutions under Felling's solution, like Felling's solution A and Felling's solution B. Felling's solution A is aqueous copper sulfate and Felling's solution B is sodium potassium tartarate. So you don't need to write the full formula into the chemical reaction. Sodium, potassium, tartarate and all, don't write the chemical formula. Instead you write Cu2 plus and OH minus. This is the complete representation of Fehling solution A and B. And this also, when you add to an aldehyde, you will get the observation of a reddish brown precipitate of cuprous oxide. Why? Because this aldehyde changes to carboxylic acid. This also only for aldehyde, and when you take ketone R2CO, we will not get the observation, no characteristic reaction. Again, to distinguish between aldehyde and ketone, we can use the same test. But there is a difference between Felling's test and Tollens test. This will be answered only by aliphatic aldehyde. When you take aromatic aldehyde, you won't be able to analyze by using this test. For example, if you are getting a question like benzaldehyde C6H5CHO and propanol CH3COCH3. So you may be thinking like this is aldehyde and this is ketone. We can go for Felling's test, but you can't. Why? Because this is aromatic. Aromatic cannot possible. So in this case, you can use only tolerance test. Why? Because tolerance test is able to answer both aliphatic and aromatic aldehydes. I hope you understood. I'll be discussing different examples and questions at the end of this. Now, iodoform test. What is the practical application of iodoform test is to distinguish between two different aldehyde. If you are getting two compounds, both are aldehyde and aldehyde, or both are ketone and ketone. There are two ketones or there are two aldehyde, then better you always go for iodoform test. If only one aldehyde and one ketone, then you always go for silver nitrate or tolerance test. And in iodoform, the condition of showing this test is C double bond O. We know that for aldehyde and ketone, carbonyl group is there. C double bond O group is there. That should be next to a CH3 group. A CH3 group should directly attach with the C double bond O group. It means this part must be there in an aldehyde or a ketone to show this reaction, and which is also called a methyl ketone. So this test is answered only by methyl ketone. Methyl ketone doesn't represent its only ketone, it can be an aldehyde as well. Got it? And the reaction is when you add NaOX. NaOX is a mixture of NaOH and X2. X2 is halogen. Sodium hydroxide and halogen. And during the reaction, this CH3 will change it into CHI3. Don't write CH3I. It is CHI3. I, why? Because if halogen is iodine. Or else we can write CHCl3 or CHBr3. It's like chloroform, bromoform or iodoform. All those are precipitate. If you are using iodoform, it is a yellow precipitate. CHI3 is yellow. So yellow precipitate formation takes place if it is methyl ketone. And that CH3 part will be replaced by ONA. ONA. Wherever CH3 is there in the reactant, that you change it into ONA. This is how we can write the reaction. So these are the important distinction tests. So I'll discuss some questions to understand in a better way. Propanol and propanone. So this is aldehyde and propanone is a ketone. So better you go for tolerance test. First you write the name of the test in the answer, which is tolerance test. Then you write the reaction. Propanol CH3 CH2 CHO. This is propanol, and during tolerance test you add silver nitrate AgNH3 twice plus OH minus. This is ammoniacal silver nitrate, and this is the aldehyde part that changes to carboxylic acid. So the alkyl group acetate CH3CH2 acetate. Then CHO changes to COO minus plus Ag. That is the silver mirror. This is the observation what we are getting. Along with that, we get some byproducts like ammonia and water. This is the complete reaction. But when you take propanone, propanone is CH3COCH3 and do the same reaction like by adding silver nitrate AgNH3 twice plus OH minus. No characteristic observation. You will not get the observation. No characteristic observation or no characteristic reaction. This is how we can present the answer. So the name of the test must be written in the answer. Similarly, acetophenone and benzophenone. Acetophenone is CH3CO C6H5 and benzophenone is C6H5 CO C6H5. Both are ketone, but the difference is the first one is having a CH3 directly attached with the CO part. So it's a methyl ketone. So we can go for iodoform test. So we add NaOI. During the reaction, the CH3 part will change it into CHI3. Don't write CH3I, which is a yellow precipitate. CHI3 is iodoform, is a yellow precipitate, and that CH3 part will be replaced by ONA. You write ONA instead of CH3. So like this you write ONA in place of CH3 and the remaining is COC6H5. Then you will not be confused. So don't change the remaining position or remaining part of the fragment. Only CH3 will be replaced by ONA. But the second one, when you add NaOI, there is no characteristic reaction. This is how we can understand the presence of acetophenone and benzophenone. Now benzaldehyde and acetophenone. Benzaldehyde C6H5CHO. Acetophenone is CH3CO C6H5. In this reaction, you see the second one is having CH3CO. Here you can write as well iodoform test, and also you can go for tolerance test. Why? Because the first one is an aldehyde and the second one is a ketone. This is aldehyde and this is ketone. But you don't write Felling's test. Why? Because the first one is an aromatic aldehyde. So if you write the tolerance test in this, if you are writing tolerance test, reaction will be AgNH3 twice. Same like the first reaction. AgNH3 twice plus OH minus you get C6H5COO minus plus Ag. This is the silver mirror. And the byproducts like ammonia and water. Got it? Same like the first question. And here I'm not writing the reactant and you will not get the observation. Got it? Now pendant 2-on and pendant 3-on. First to understand the structure. Pendant 2-on is CH3, CH2, CH2, COCH3. This is 2 on. And 3 on is CH3, CH2, CO, CH2, CH3. You see this? First one is having a methyl group attached directly with the CO. But second one, it's not directly. So that the second one will not be giving iodoform test. Both are ketone. So iodoform test. And during iodoform, you add NaOI. First you write the product, the observation, which is CH3 will change it into CHI3. That you write separately first itself. And in bracket you must write yellow precipitate. Okay. And now the main product is CH3, CH2, CH2, CO. After CO, instead of CH3, you write this ONA part. ONA. So COONA, which is a carboxylic acid, sodium salt of carboxylic acid. But the second one, when you add NaOI, no characteristic observation. I hope we understood. Ethanol and propanol also same only. CH3, CHO is ethanol, and propanol is CH3, CH2, CHO. So here the first one is having a CHO directly with C double bond O, so iodoform test will be answered. The second one, iodoform test won't be answered. So you write the reaction. Next, phenol and benzoic acid, one alcohol and one acid. So this can be understood by using sodium bicarbonate test. So the test name is bicarbonate test. Bicarbonate test is answered only by acid, not for phenol. So you take acid, which is benzoic acid in the question, and add NaHCO3, that is sodium bicarbonate. And the product is this hydrogen in benzoic acid is replaced by sodium, which is C6H5COONA. Along with that, you will get the brisk effervescence of carbon dioxide and water. So by observing the brisk effervescence, you can understand that is carboxylic acid. But if it is phenol, C6H5OH, when you add sodium bicarbonate, you will not get this observation. No brisk effervescence, so no characteristic observation because of the absence of acid group. It is alcoholic group. So only acid group gives bicarbonate test. So these are the important distinction test comes in this lesson: aldehydes, ketones and carboxylic acid. So in your textbook, so many questions are there. Go through all the questions and in this way you practice the questions and try to get it. So mainly three, like Felling's test, Toland's test and iodoform test. And bicarbonate test is only for carboxylic acids. So I hope you understood. Thank you all.